So where do these numbers live? They live on a number line. And I'm sure you've seen this before, where you put a 0 right here in the middle, and then you have like 1, 2, 3, -1, -4, and so on. And all of the numbers that we could be concerned with live on this line. So, for instance, 1/2 lives right here. -7/2 lives here. Now, little tangent about improper fractions versus mixed numbers. I can see the benefits of when you're first learning about fractions, why mixed numbers are there. If I were to tell you where does 7/2 live, or -7/2 lives on the number line, it would take you a minute to try and figure it out, and you'd still have to do like the division to find out what its whole number value is, which in this case is -3. This is much easier to think about and locate on the number line. But as far as applying it towards algebra, all of the manipulations that we're going to be doing there, improper fractions are where it's at. And then pi, as a non-rational number, we can put pi right there. Remember, it's 3.14 and so on. So it lives just a little bit above 3. The reason why we can bring up the number line is because it's useful when it comes to ordering numbers. Now, obviously, there's stuff like 0 is greater than -2, and then 3 is greater than 1. This is well ordered, which means that we can always rely on numbers being bigger than other distinct numbers. And we use symbols for that. So I originally said 0 is greater than -2. That's what this symbol is. Again, probably have seen this before, but we're going to be doing a lot more stuff than just stating stuff like this, but I want to make sure we're all on the same page. And then, what did I say? Like 1 is less than 3? I probably said the other way around, but just to show you that there's this. I still say this to this day, that the alligator mouth wants to eat the bigger number. Me with the math degree doing this for you guys. So we have a number line. What if I told you that we can actually write 2 number lines kind of like on top of each other? Not like on top of each other like that. That wouldn't do anything. But actually we're going to kind of rotate it and put it exactly perpendicular to each other, or exactly at a right angle. Yes, these are 2 separate number lines. Still have to label them kind of like what we were doing before. So 1, 2, 3, -4. And unsurprisingly for this number line, it's going to go in ascending order, going from bottom to top. So 1, 2, 3, 4, like that. And then going down, it'll be -1, -2, -3, -4. And this in the middle, this point right here is actually where these 2 number lines intersect, called the origin. When it comes to plotting numbers on a number line, we just kind of say a number and then plot where that number is. But here we have 2 number lines, so we need 2 separate values indicating where it wants to be across this entire grid. We're not just putting it on the lines anymore. We're actually going to be putting points around here like that. And in order to do that, we need to first say how it's going left and right and how it's going up and down. And it's actually that order. So this is the x-axis, this is the y-axis. What does that even mean? Well, we're going to be plotting coordinates. Each point on this grid is going to have 2 values, signifying how much left and right it goes, and then how far up and down it goes. So this is the form of any coordinate point that you're going to want to plot. To give you an example, I'm going to plot the point 2, 3. and it goes 2 in the x direction. So I'm going to start at the origin, always start at the origin, then go 1, 2. Okay, stop. That's where that number would be if it was just the number 2, right? That's going left and right. Now for the y-coordinate, that is going to signify if we're going up or down at all. And we are going up by 3, not from the origin, because we've already gone over by 2. We want to know where 2, 3 is. So 2, 1, 2, 3. Right there. Cool. Let's do another example. So we got like -1, 4, let's say. All right, so we want to move in the x direction. We want to move in the left and right direction by -1. So we want to move to the left by -1. Then we want to go up again by 4. 1, 2, 3, 4. Cool. We can still plot numbers on the one original number line if we really wanted to. That just means that we have to place a 0 in the y-coordinate, telling us that we don't want to go up and down at all. So this would just be 1, 2, 3, just like that. This is the same thing as the number 3 on our regular one-dimensional number line. And I'm sure you've guessed that the coordinates for the origin is simply 0, 0. Right? No up and down, no left and right. Now, usually when we plot points, we could give them names. So this one is going to be called Polly. No, we don't name them like that. We can name them by just a letter. And then we would go like P, like point P is equal to that. Say that this is point Q. So then we put the Q over there. Then this is point R, I guess. So then point R is right there. And then this is the origin. You can label the origin a name and RS, let's say. Let's say O for origin. And the reason why we want to potentially name these is to kind of quickly reference which point we're talking about rather than looking at the coordinates again. And we might want to graph polygons. And in order to do that, we're going to draw line segments in between these points that we've freshly named. And this. See how I'm drawing the outside of this? I could connect these points there, but that's not giving me the full quadrilateral that I'm looking for right here.